operations on real numbers. You already know that rational numbers satisfy the commutative, associative and distributive laws for addition and multiplication. You also know that rational numbers are closed under addition, subtraction, multiplication and division except for 0. What does it mean? It means that whenever you add two rational numbers, subtract two rational numbers, multiply two rational numbers or divide any two rational numbers except for 0, you will always get a rational number. Moreover, it turns out that irrational numbers also satisfy the commutative, associative and distributive laws for addition and multiplication. But in the case of irrational numbers, it is not necessary that whenever you add, subtract, multiply or divide any two irrational numbers, you will always get an irrational number. Sometimes you can get a rational number as well. Let us understand this with the help of few examples. Suppose you have an irrational number, say root 5. If you add minus root 5 to it, you will get 0. 0 is a rational number. Let me write down one more example. If you add 2 root 5 to 3 root 5, what will you get? 5 root 5. This is an irrational number. Let me write down some examples on subtraction. Suppose you have root 7 and you subtract root 7 from it, you will get 0. This is a rational number. Now let us take 4 root 6. From this, if I subtract 3 root 6, I will get root 6. This is an irrational number. Let me write down some examples on multiplication. Suppose you have root 3 and you multiply this to root 3, you will get 3. This is a rational number. Let me write down one more example. If you multiply 2 root 3 with root 2, you will get 2 root 6. This is an irrational number. Let me write down some more examples. This time I'll write down on division. Suppose you have root 8 and if you divide this by root 8, what do you get? 1. This is a rational number. But if I divide 2 root 3 by root 6, I will rewrite this as 2 root 3. Root 6 I will write as root 2 into root 3. So this will be cancelled. When you divide 2 by root 2, you will get root 2. This is an irrational number. So you must have noticed that whenever we are adding, subtracting, multiplying or dividing any two irrational numbers, sometimes we are getting a rational number and sometimes we are getting an irrational number. Let us now discuss what happens in that case whenever we add, subtract, multiply or divide a rational number with an irrational number. We are going to understand this with the help of this question. So here the question is saying, check whether 7 root 5, 7 upon root 5, root 2 plus 21, pi minus 2 are irrational numbers or not. So you need to check whether these numbers are irrational numbers or not. So let us first solve this one, 7 root 5. So 7 is a rational number. You are multiplying this with an irrational number, root 5. First we will write down root 5 in decimal form. To write down root 5 in decimal form, you have to use long division method, and using that you can easily write down root 5 in decimal form. Let us now multiply. So 7 into root 5 in decimal form is 2.236 and so on. So 7 into 6 is 42, carry over 4, 7 is 21, plus 4 is 25, carry over 2, 7 is 14, 14 plus 2 is 16, carry over 1, 7 is 14 and plus 1 is 15. So what do you get? 15.652 and so on. So this is non-terminating, non-recurring decimal number. That means it is an irrational number. Let us now solve this one. So 7 is a rational number. You are dividing with an irrational number, root 5. So we don't know how to divide a rational number by an irrational number, but we know how to divide by a rational number. So what we are going to do is we are going to convert the denominator into a rational number. To do that, we will multiply here both numerator and denominator by root 5. So in numerator you will have 7 root 5 and in denominator root 5 into root 5 gives you 5. This is a rational number. Now we can easily divide it. 7 root 5 value you have already calculated here in decimal form. Let us write it down. So that is 15.652 and so on. You are dividing it by 5. So when you divide, you will get 5 3s are 15, decimal point above the decimal point, 5 1s are 5. Then 5 3s are 15, 2 will not go, so 0, 5 4s are 20 and so on. So here also you get non-terminating, non-recurring decimal number. So here also you got an irrational number. Now let us solve this one, root 2 plus 21. So root 2 is an irrational number. We are adding 21 to this. To find out the decimal expansion of root 2, again you have to use long division method. So now let us write it down. Root 2 value is 1.4142 and so on. To this we have to add 21. So 21 plus 1 is 22 and after the decimal point you have 4142 and so on. So here also you got non-terminating, non-recurring decimal number. So this is also an irrational number. Now let us solve this one. Pi minus 2. Pi is an irrational number. From this we are subtracting 2, which is a rational number. The value of pi is 3.1415 and so on, minus 2. So 3 minus 2 is 1. And after the decimal point you have 1, 4, 1, 5 and so on. So here also you got an irrational number. You can clearly see this is non-terminating, non-recurring. So it is an irrational number. So now let us summarize that whenever you add or subtract a rational number from an irrational number, you will always get an irrational number. But whenever you multiply a rational number, it should be a non-zero rational number. Okay, so whenever you multiply or divide a non-zero rational number with an irrational number, the result is an irrational number. So let us now discuss some more questions based on the points which we discussed just now. So the first question is add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. So we have to add these two irrational numbers. So let us add them. So we have 2 root 2 plus 5 root 3. To this irrational number, we have to add root 2 minus 3 root 3. So what we are going to do? We are going to regroup them. So 2 root 2 and this root 2 I am writing it here plus 5 root 3 and then minus 3 root 3. So here you can take root 2 common. I am applying distributive property here. So inside the bracket you have 2 plus 1. Here I can take root 3 common. So inside the bracket you have 5 minus 3. So 2 plus 1 is 3. So you get 3 root 2. And here you get 2 root 3. So you got an irrational number. Now let us solve this one. Multiply 6 root 5 by 2 root 5. So here we are multiplying two irrational numbers. So 6 root 5, you have to multiply this with 2 root 5. So when you multiply, 6 into 2 is 12 and root 5 into root 5, you will get 5. So 12 into 5 is 60. This is a rational number. Here you have multiplied two irrational numbers and you got a rational number here. Now let us take this question. Divide 8 root 15 by 2 root 3. So you have to divide 8 root 15 by 2 root 3. So you can cancel it out. I'll just rewrite it here first. So 8 root 15, I can write it as root 3 into root 5. And in denominator, you have 2 root 3. So you can cancel root 3, 2 and 8 you can cancel. You will have 4 here. So you got an irrational number 4 root 5. So here you have divided an irrational number by an irrational number, and the result is here an irrational number. Let us now discuss the operation of taking square root of real numbers. Quickly recall that if a is a natural number, then square root of a is equal to b, which means that b square is equal to a, and here b is greater than 0. If you square on both the sides, what will you get? B square is equal to a. So you can clearly see here that a is a perfect square of b and b is square root of a. The same definition is extended for real numbers as well. So let a be a real number and here a is greater than 0. So square root of a is equal to b, which means that b square is equal to a, and here also b is greater than 0. Earlier in this chapter, we have seen how to represent root n on the number line, where n is a positive integer. Let us now see how to represent root x geometrically, where x is a positive real number. We will understand this with the help of one example. So let us assume that x is equal to 3.5. So we will locate square root of 3.5 geometrically. To do that, on a given line, okay, at the end point, we will mark this point A. On the same line, at a distance of 3.5 units, we will mark this point B. And at a distance of 1 unit from B, we will mark this point C. So here, all these 3 points A, B and C lie on the same line. Now we will find out the midpoint of this line segment AC and name that point as O. So taking O as the center and OC as the radius, we will draw this semicircle. Now we will draw a line perpendicular to this line segment AC, passing through this point B and intersecting the semicircle at this point D. So here BD is square root of 3.5. So we will follow the same steps to locate root x geometrically. So let us start. On a given line, at the end point, we will mark a point A, and on the same given line, at a distance of x units, we will mark this point B. And from B, at a distance of 1 unit, we will mark this point C. Now we will find out the midpoint of this line segment AC, and we will name that point as O. Taking O as the center and OC as the radius, we will draw this semicircle. Now we will draw a line perpendicular to this line segment AC, passing through this point B and intersecting the semicircle at the point D. So here BD is root x. So how is that BD? We are saying that it is root x. Let us understand now. So you can see here this angle ABD. This angle is 90 degrees because we have made this line segment BD perpendicular to this line segment AC. So this angle over here is 90 degrees, and in a right angle triangle, we can apply a Pythagoras theorem. So here this triangle OBD is a right angle triangle, and we can apply the Pythagoras theorem here. So using the Pythagoras theorem, we can find out this BD. So to find out BD using Pythagoras theorem, we should know how much is OB and how much is OD. So you can see that OD and OC both are equal because they both are the radii of this semicircle. And how much is the diameter? X plus 1. And radius is half of the diameter. So let us now find out how much is OC or how much is OD. So these two are radius, so that will be half of the diameter. Diameter is x plus 1. Divided by 2 gives you the radius. So you got to know how much is OD. Now we have to find out how much is OB. That is simple. From OC, if I subtract this 1 unit, we will get this OB. Let us find out. So OB is equal to, from this OC, how much is OC? X plus 1 upon 2 is your OC. If I subtract 1 from this, we will get OB. So we can rewrite 1 as 2 by 2, right? So OB is equal to x plus 1 upon 2. This 1 I am writing as 2 by 2. So here in numerator you have x plus 1 minus 2. So plus 1 minus 2 gives you minus 1. So in numerator you have x minus 1 upon 2. So you got how much is OB. So we got these two now, OD and OB. Now let us find out BD using the Pythagoras theorem. So using the Pythagoras theorem, BD square is equal to OD square minus OB square. And how much is OD square? OD square is x plus 1 upon 2 whole square minus OB you got as x minus 1 upon 2 whole square. So here you can use two formulas. One formula is a plus b whole square. You can apply this and open it here. And here you can use a minus b whole square and solve it. Or you can use a square minus b square. I am going to use the second one, a square minus b square. Here a is x plus 1 upon 2 and b is x minus 1 upon 2. So a plus b, how much it will be? It is a is x plus 1 upon 2. This is a plus b. This is your b. So x minus 1 upon 2 into, now we will do a minus b. A is x plus 1 upon 2 minus b is x minus 1 upon 2. So here you have x upon 2 plus x upon 2. So that is x. And here 1 upon 2 and minus 1 upon 2. So both will be cancelled. So here you have x. And here x upon 2 minus x upon 2 will be cancelled. Here 1 upon 2 minus 1 to minus is plus 1 upon 2. So 1 upon 2 plus 1 upon 2 will give you 1. So x into 1. So you got BD square as x. So if you take square root on both the side, you will get BD. So BD is equal to root x. So now you have understood why BD is square root of x. So this construction shows the visual and geometrical way of representing root x, where x is a positive real number. If you want to represent this root x on the number line, we will treat this BC line as a number line. So here we will take B as 0, C as 1 and so on. Now taking B as the center and BD as the radius, we will draw this arc. So it will intersect this number line at this point E, and this is your root x. Let us now extend the idea of square roots to cube roots, fourth roots, fifth roots, or in general nth roots. Let us quickly recall the concept of square roots and cube roots. So if I ask you what is cube root of 8? So you know that that is a positive number and that is 2. I can write the same thing as 2 cube is equal to 8. When you multiply 2 3 times, you will get 8. Now if I ask you what is the fifth root of 243? So if you are not able to calculate it mentally, then you have to do the prime factorization of 243 using the prime factorization method. And when you do that, you will find the factors of 243 is 3 is multiplied 5 times. So this is fourth time and this is the fifth time. So you have to find out the fifth root of 243. That means you have to make group of 5. So here you can see that 3 is in a group of 5. So when you take the fifth root of this, you will get 3. Or we can write the same thing as 3 raised to the power 5 is equal to 243. So using these examples, let us generalize that if a is a real number which is greater than 0 and n is a positive integer, then nth root of a is equal to b if b raised to power n is equal to a. Are you able to relate it? See here, b raised power n is equal to a. So here 3 raised power 5 is equal to 243. Or you can say that fifth root of 243 is 3. So that is written over here. Nth root of a is equal to b. Please note that this symbol which is used here, here and here is called the radical sign. Let us now see some identities related to square roots. Here a and b are positive real numbers. So the first identity is square root of ab is equal to square root of a into square root of b. Let us understand this. So here square root of a, I can rewrite it as a raised power 1 by 2. Cube root of a, I can rewrite it as a raised power 1 by 3. Or the nth root of a, I can rewrite it as a raised power 1 by n. So here we are using one law of exponent. Which is that law? AB whole raised power n is equal to a raised power n into b raised power n. Let us replace n with 1 by 2. So here AB whole raised power 1 by 2 is equal to a raised power 1 by 2 into b raised power 1 by 2. Now I am going to use this concept here and rewrite like this. So here I can rewrite it as square root of AB is equal to square root of A into square root of B. So I hope you must have understood how this has come. Now let us take the second identity. Here also we are going to use some law of exponent. So let us see what it is first. So square root of A by B is equal to square root of A upon square root of B. So let us see using which law of exponent we have got this. So you know that a by b whole raised power n is equal to a raised power n upon b raised power n, and let us replace n by 1 by 2. So here you have a by b whole raised power 1 by 2 is equal to a raised power 1 by 2 upon b raised power 1 by 2. So using this logic again here we can rewrite this as square root of a by b is equal to square root of a upon square root of b. So is it clear now, this identity? Now let us move on to the third identity. Here inside the brackets you have square root of a plus square root of b. This is multiplied to square root of a minus square root of b, which is equal to a minus b. Here also we have used one identity which you have learned in your previous classes. Let me write it down. So that identity is x minus y into x plus y, that is equal to x square minus y square. So instead of x you have root a and instead of y you have root b. So I'll just replace x with root a and y with root b. So using this identity we have to take the square of square root of a minus square of square root of b. So I can rewrite this as using this one, a raised power 1 by 2 whole raised power 2 minus b raised power 1 by 2 whole raised power 2. So again we are going to use one law, power of a power, a raised power m whole raised power n is equal to a raised power m into n. So you just multiply the powers. So here what you will get, a raised power 1 by 2 into 2, so you can cancel this, minus b raised power 1 by 2 into 2, you can cancel this, what do you get? A minus b, just written over here. Now let us take the next identity. Here inside the brackets you have a plus square root of b, which is multiplied to a minus square root of b. This is also inside the brackets. So using this same identity, you will get it as a square minus b. You have to take the square of a, so you will get a square minus sign, and square root of b is b. Now let us move on to the next identity. So here inside the brackets you have square root of a plus square root of b. This is multiplied to square root of c plus square root of d. So here distributive property is used. How? When you multiply square root of a to square root of c, you get square root of ac. Then you will multiply square root of a to square root of d, you will get square root of ad. Then square root of b into square root of c, you will get square root of bc. Then you will multiply square root of b to square root of d, you will get square root of bd. So this is how you will get it using distributive property. Let us move on to the last identity. So here you have inside the brackets square root of a plus square root of b. You have to take the whole square. So here also you can use one identity which you have used in your earlier classes, that is a plus b whole square, that is equal to a square plus 2ab plus b square. So let us do the same thing here. So you have to take the square of square root of a. So you will get a twice of square root of a into square root of b. So that will give you twice of square root of ab. And then you have to take the square of square root of b. So you will get b. Let us now take one question based on these identities. So the question is, simplify the following expressions. What do you mean by this word simplify? Simplify means you have to solve this and write down your answer as the sum of a rational number and an irrational number. So let us solve it now. So here inside the brackets you have 5 plus root 7, which is multiplied to 2 plus root 5. So you are going to use which identity? You are going to use this identity, that is distributive property you have to apply here. So 5 into 2 gives you 10, then plus 5 into root 5, you will get 5 root 5. Then you will multiply root 7 to 2, so you will get 2 root 7. Then you have to multiply root 7 to root 5, so you will get square root of 35, because 7 into 5 is 35. So you can see that you have written the answer as the sum of a rational number and irrational number is here. Now let us take the next question. So here inside the brackets you have 5 plus root 5, which is multiplied to 5 minus root 5. So this is similar to which identity? It is similar to this identity here. So using that, you have to take the square of 5. That is 5 square minus, what is written over here? Minus b. So that is 5 here. So 5 square is 25 minus 5. So that is 20. Now let us take the next question. You have to take the square of root 3 plus root 7. That is whole square. Whole square of root 3 plus root 7. So that means you have to use this identity. So it is a plus twice of square root of ab plus b. So here your a is 3 and b is 7. So here a is 3 plus 2 root a is 3, b is 7 plus b. So here b is 7. So 7 plus 3 is 10, and then you can simplify this to square root of 7 into 3 is 21. Now let us take the next question. So inside the brackets you have square root of 11 minus square root of 7. This is multiplied to square root of 11 plus square root of 7. So this is exactly same as this identity. So here a is 11 and b is 7. So using that we have a minus b. So what do you have here? 11 minus 7, and that is equal to 4. Now let us take the next question. Rationalize the denominator of 5 upon root 3 minus root 5. So what do you mean by this word rationalize? It means you have to write down the denominator as a rational number. You can see the denominator is an irrational number. You have to make this denominator as a rational number. So what we are going to do? Let me just write it down. So here in the numerator we have 5 and in the denominator root 3 minus root 5. So to make the denominator as a rational number, if you multiply this by root 3 plus root 5, we'll get a rational number. You can see here, you are multiplying here, instead of a, it is 3. Instead of b, it is 5. So if you multiply this with this, you will get a rational number. So that is what we are going to do here. So I am going to multiply here with root 3 plus root 5. So same number I have to multiply in the denominator as well. Root 3 plus root 5. So you are multiplying this. So in the numerator you have 5 into root 3 plus 5 root 5. And in the denominator you have 3 minus 5 because this is a minus b. So here what will you get? 5 root 3 plus 5 root 5 upon 3 minus 5 is minus 2. So you have rationalized your denominator.